Welcome everybody to this week's installment of our webinar series. Really excited today to be doing this in partnership with QDrant, where we're going to be talking about the limitations of naive RAG and looking at how we can overcome some of these limitations with some slightly more complex agentic RAG systems that can overcome some of these shortcomings. Maybe to start off, before diving into the slides, it'd be good to do, me and Atita can do some quick intros. So a very quick intro on my side. There's a lot of autopilots with introducing themselves. Hello, all of the autopilots. So on my side, found at Unify, where we're basically building a dynamic router to choose the best LLM on every prompt and do so in an automatic manner. So that's kind of what we're building in a nutshell. And today, not focusing on the router so much, really just looking at some of the benefits of Unify's single sign-on, being able to test out different models and stuff in a very flexible way. So that's a quick intro on my side. Maybe Atita, do you want to give a quick intro on your side as well?
Sure. Thank you, Daniel. So pleased to be here. Hello, everyone. My name is Atita, and I work as a solution architect at QDrant. So I've been in the information retrieval space since 17 years now. So retrieval, augmented generation is like the new information retrieval system these days, and which is why you see me here. So excited to be here and looking forward to all the questions. Thank you.
Awesome. Yeah, we're really excited to dive in as well. I mean, I see people still piling in, so it's great to have such a big audience. There's 38, I guess. When we include the autopilots, I guess people will be listening to this asynchronously as well. Amazing. Well, yeah, great to have everyone here. So yeah, without further ado, let's dive in. So let me quickly get my screen share up. There we go. So yeah, as I'm sure, well, maybe not everybody. We obviously welcome people from all different backgrounds. So maybe not everybody does know what RAG is, but certainly one of the hottest three-letter words in Gen AI right now is RAG, which for those that don't know means retrieval augmented generation. In a nutshell, what this means is that what LLMs do is they generate responses to questions, of course, but often without giving the LLM context to or kind of more information, the LLM only is able to go off its internal knowledge. So whatever the pre-processing step for the LLM was, whatever kind of corpus of text the LLM is trained on, that's the only thing that it's going to know anything about, and therefore hallucinations are very likely. You can't expect, even a model as big as GPT-4, you can't expect it to know about your internal documents because they're not on the online data that obviously GPT-4 was trained on, for example. And that's where you need to augment the generations of these LLMs with information that you've retrieved from your personal particular data sources so that the LLMs are able to reason about broader information than was contained in their pre-training data, basically. So that's kind of in a nutshell what RAG is all about, for those that don't know. So existing techniques, there's a lot of techniques out there. A lot of them are very brittle and don't really work when you push them to their limits. There's a lot of great work trying to overcome some of these shortcomings. We'll be focusing on one such approach in this talk, but one of the broad pictures really is that RAG is a very fast evolving field. There's a lot of research going on, a lot still to be done to improve these systems, and quite a complex landscape that we're going to be diving into. So firstly, basically, as I'm sure everyone's aware on the call, Gen AI is being adopted very quickly. There's some nice graphics here showing some of the Gen AI use cases in Indian organizations. There's a lot about intelligent assistance for very specific tasks. This is kind of your co-pilots or your talk to your data kind of things. Document intelligence kind of part of that as well. Coding assistance, pretty common as well. Customer-facing chatbots, that's already a huge industry, obviously, and now that's being improved and augmented with LLMs as well. Marketing automation, so generating creative material, so blog posts and so on is also very big. So these are some of the really big use cases we see for Gen AI in general. And in terms of the impact, so we see here things that are already possible in the middle, in the orange, and as we go further out, we see some of the slightly longer term kind of goals of Gen AI. So simulation twins, workflow tools agents, multi-agent generative systems, and all this kind of stuff, which is still in the field of research, much of this, but over the next few years, we'll start to see more and more of this in industry as well. Yeah, so a very fast-moving field. So while this looks, potentially somewhat complicated, this is a somewhat simplified view of how complex RAG can actually get. So there's a good way of thinking about RAG for now is that there's these three different ways of considering it. So the simple naive RAG, basically you have your documents that come in, you then have a query, and all you do is you embed the documents using some encoder, you embed the query using some encoder, and then you do some very simple similarity search between the two, retrieve the chunks from the documents that are closest to your query in this latent vector space, and then you append your query with that context, and you assume and hope that there is enough context there to answer the question. And that might work with very simple data stores where the words have very semantic closeness with the chunks in the query, but for more complex stuff, this generally breaks down. So what you can do is take this naive approach and augment it with some treatment on the input and output. So we can take the query in, and we can then rewrite parts of the query to make it better. We can expand the query to make it more rich in data. We can do some routing, for example, to actually just try to make the query as suitable for this kind of latent comparison as possible. And then on the output, we can do the same. We can do some re-ranking. We can fuse multiple queries. We can do like summarization and so on to try to make the most of the document retrievals that have come out. Summarization, for example, would be very good if we have a very large chunk size and we retrieve lots of information and so on. But so this can help, but it is a little bit like adding a band-aid to a system that might be fundamentally not the right approach. So you can't, if there is just not semantic similarity to your query and the chunks, then any of these input and output treatments isn't going to solve your problem. And that's where slightly more bespoke agentic systems come to play, where you can actually, as an engineer, you can actually design your system so that you have a much better hierarchy and a much better process control flow as to how you expect the agentic system to work. So you can define tools that heuristically would be useful for solving the tasks, such as getting the entire, I don't know, in our case with emails, getting the entire email conversation between two people, finding all of the emails from this organization, and so on. So you can actually take your RAG application and start to embed some task-specific information into the tools that you make available and so on, and then you can end up getting much better performance, as we'll see in the examples today. So a quick note on both QDrant and ourselves. So for those that don't know, QDrant is an enterprise-ready, massive-scale vector search technology for the next AI generation. So lots of great metrics. So there's over 10,000 adopters worldwide, over 5 million downloads, over 8,000 GitHub stars. So yeah, definitely check QDrant out if you haven't already. And obviously throughout this demo, if you follow along, you'll be creating an account as part of the demo process as well, and starting to use the cloud-based vector databases in terms of Unify. So we provide the best LLM on every prompt. But beyond that, we also provide single sign-on for all models and providers. So if you want to quickly play around with Mistral and Anthropic Claude and GPT-4 and Llama and so on, and you want to just play around with all these models and not create a ton of different accounts and a ton of different input-output representations, then you can do all of that through Unify. You can also benchmark your own tasks to get these custom dashboards to see which models and providers are the best for your particular task on your particular prompts. And then the cherry on top is that you can actually get better optimized deployment with our router, which is where we get the best LLM on every prompt. So a bit about the two companies there. So as for the topic of the talk, so we're making the argument that naive RAG often doesn't work well. And this is not anything new. This is well documented by industry and research alike. So some of the challenges of naive RAG are as follows. So they face inherent limitations of information retrieval and dependence on LLMs. And some of these failure points are listed here. So you can imagine the user makes a query. Now the query is fragile. It might be imprecise. It might be misleading. Might not have semantic closeness in the latent space to the information that's actually needed to answer the query. That's a really important one. So then you get the query, you embed the query in the same space as the document chunks are embedded, and then basically you retrieve the relevant documents using some kind of similarity search. Now these documents might have wrong cutoff points if the chunking hasn't been done right. Might have missed top ranked documents, and there might be domain specific ranking expectations. And more broadly, it might be the case that just the query doesn't actually contain the semantic closeness to the question you ask might not actually have a semantic latent representation that is close to the documents that are needed to answer the question. And we'll see this in the examples today. So then you get generation, and you might have incomplete or inconsistent generations, which then result in answers that are unfaithful, wrong format, etc. So these are just some of the issues with naive RAG. So there's all kinds of techniques for enhancing RAG. Of course, we won't go through all of these today, but I mean, suffice it to say, if you just Google RAG improvement techniques, then you'll see all kinds of graphs like this. Here's just a few of them, things you can do. And we've plotted these here in terms of the degree of complexity on the x-axis and the projected contribution to the quality on the y-axis. So generally speaking, one thing you could say is that top left is quite a sweet spot where it's simple to implement and high impact. So metadata filtering is one thing that's pretty impactful. But when you really want to get the very best, then things such as retrieval augmented reasoning, etc., are very good, where you can basically retrieve and then kind of re-reason about the retrievals and iterate accordingly. Similar to kind of adaptive retrieval and self-RAG as well. And this is the kind of area that we're going to be looking at today, where basically, well, to some extent this area, where basically with tools we can kind of get a retrieval, and in this kind of React style format can continue reasoning about what the next best step is based on what we've managed to retrieve so far, and continue doing so until the LLM is happy that it has the answer, only at which point it will then trigger to be finished. So this is very much taking the React footprint. So that's the background. Now we'll be diving into the notebook itself, which you should be able to get from this QR code. Otherwise, what I'm also going to do is add it into the chat on the meeting. And so let me quickly do that now. So this is the notebook. Also, this will be on the YouTube video we had afterwards, of course, as well. So for those in the meeting, the link has just been added on the chat. So you can open the chat up and just click this notebook. And then you can follow along. I'll actually just briefly share my entire screen just to show you again also how you can do this. So one moment. Let me just share this screen. So yeah, the link I just shared with you is this. What you can then do, obviously, just open a Google Colab. So you can just go, type Google Colab, and then you can enter in. So I mean, if you did like this, Google Colab, you just go to a Google Colab like so, and then you can do GitHub and then add a URL and just copy this URL into here when you go into Colab, and then it will open up. It will open this up for you, which is what I've done here. So again, for those that are on a computer, I would very much recommend following along, because that'll be where you get the most benefit. And also, of course, you can make changes to the code and play around with it and experiment yourself. So I guess any questions for those following along? Anybody having trouble bringing this up in a Google Colab? If not, then I'll make a start. And if there are any questions, again, no such thing as a silly question. No need to be shy. Just feel free to raise your hand, and we can help out making sure you manage to get this set up correctly for the best experience. Okay, well, I'll assume that everyone that wants to follow along has got it set up, so we'll dive in. So yeah, so in this notebook, we'll be exploring some of the shortcomings of naive RAG, and then we'll end up building a more robust RAG pipeline, which uses agentic approaches that utilize various email tools that we build for this particular use case. So we'll be using Unify for querying various large language models. In this case, mainly just demonstrating that you can have a single sign-on with one API key that supports all models across all providers. So that's kind of the benefit being demonstrated here. We're using QDrant for building the RAG engine and the vector database management. So yeah, this is a vector similarity search engine that offers lots of APIs to store, search, and manage vectors. So this is how we'll be using the two platforms. So first of all, we install all the dependencies. So we install the QDrant client, we install fast embed for the embedding the prompts and the chunks, Unify AI, a few things for environment variables and data processing and visualization as well. So we just get these installed. So now we get set up with the API key. So first of all, for Unify, what you do is you go to the console page, we redirect accordingly, and I'll just quickly log out so you can see what happens. So that's my personal account. So all you need to do when you go to Unify, you can either log in and sign up with GitHub, with GitHub or Google. I've done it with Google, but you can use either of these. So then you just click here and select the account you want to use, and then you'll be taken to your dashboard accordingly. Then you can copy your API key like so, just pressing this copy button. And then what you should do is go into secrets, add a new secret, give it the name Unify key, and paste in your key here, and then make it available to the notebook. So you just tick this to give notebook access. So again, just this left-hand key, Unify key, paste it in here, tick this, and it will get access. So that's the first step. Then we do the same for QDrant. So we go to QDrant sign up page. Again, I've already signed up myself, so I'll just quickly log out if I can work out. How do you know how I log out, Atita?
On the right hand side, yeah.
Yeah, I got it. Yeah, log out. Awesome. Yeah, so what you do is you, again, same as before, you go here, you can sign up with GitHub, sign up with Google. So in the case, I'm going to go Google again. Again, click like this. And well, actually, let me quickly do this with routing, just because then you can get the full experience of what the very first thing is when you sign up. So continue. Oh, so I think that's actually probably because I've already signed up with this one. Yeah, so actually, because I've already signed up, because there's a very nice flow where basically you are. I mean, I guess I didn't do the screen share. Basically, when you sign up for the first time, it will ask you for step one to create a cluster name. Just create it kind of rag demo or whatever. Give it a very simple name, and then basically you'll be able to get. You'll be asked to generate a key. And then exactly the same as before, you do your QDrant API key, you do it as a new secret, you make it available, and you paste your key in here. And then what you'll also get is a QDrant URL, which you then call QDrant URL and add it like here again. So you need these three environment variables with these three things. Let me quickly go back to. I'll just log into my account. And I'll go to my clusters. Once you've got your cluster set up, you'll be able to open this up. And hang on, I'm trying to. Yeah, I mean, do you remember how? Sorry, obviously you know this platform better than I do. The best way of getting the view where you have the where I have the URL and the API key. I know this is very simple as you get set up with the workflow, but do you know where I can find it here?
So you would have to click on the dashboard. That's the best way to go about it.
The dashboard, which is
it was hovering on. So if you would click on the rag demo or this one, yeah.
Yeah, I've got it here exactly. So sorry. Yeah, so you have this create your first cluster. This really nice thing. So you give it a name, you get an API key, you copy the API key, and then you build it, and then basically. What you then have is you've already copied your API key that was generated here on the second step, and then the URL is just this basically. So you can then just copy this URL, in this case for my rag demo, and then copy that one here as well, basically. Yeah, any questions on getting these three keys set up? If not, then I'll move on. But if so, then just feel free to message in the chat, and obviously Atita can help answer any questions you have about that. Okay, cool. Well, let's move on. So this is how we're going to be doing it. We're managing it through the Google Colab secrets. Alternatively, you could save these as environment variables if you're running this locally, for example, but we keep these commented out for now. Let me just close this as well. Okay, so So the way we're going to, so you can use QDrant in various different ways. You can use QDrant Cloud or use it locally, but today we're going to be using the cloud. So now we just import the QDrant client, and we also import Unify. We create the Unify client as so, with the Unify key passed here. And for now, we're just going to be using Llama 2 with Together AI. And then we create the QDrant client like so, again, with the URL and the QDrant key. So we set the clients up for Unify and QDrant. So now we're just going to build a data set. So again, we're now going to be focusing on a hypothetical example where you want to build a pipeline to talk to your email inbox. It'd be great if you could just say to your inbox, hey, inbox, I chatted to somebody about a webinar I chatted to somebody about a workshop 3 weeks ago, but I can't remember who it was, and I can't remember how we left it. Can you please find this email exchange for me? Or you might want to say, hey, how many people have reached out about jobs in the last month? I've forgotten. We've had quite a lot, but I can't remember how many people that was. So this ability to really just talk to your inbox and get answers is kind of the use case that we're imagining here. So what we've done is we've created a very simple toy data set of representing such an inbox. So in case one, we have an AI conference invitation where there was an email exchange between Jane Doe and John Doe, where Jane initially agreed to attend the conference, but then later cancelled due to some unexpected work. And this was in a response to an invitation from John. And we're assuming that we are John. It's our inbox that we're basically wanting to manage. So we create this case just as this list of dictionaries representing all of the emails, the from, the to, the date, the subject, and the body. Case 2 is a paper reading invitation email. We do a lot of paper reading groups, so something that kind of comes from an internal use case. So in these emails, John invited Jane Smith, Alex Johnson, and Bob Smith to present their papers in the reading group. Bob Smith accepted the invitation to present, while the other 2 authors didn't reply. So this is some email data for this. And then case 3, we have welcome and follow-up emails. So an email exchange between Alex and again, John, who is basically us for all intents and purposes, where Alex welcomes us, John Doe, to the NDS, and expresses interest in learning how we find it, and then they continue to follow up without getting a response, and then sending more announcements. So kind of just some inbound marketing material basically coming from Alex about NDS. So we get that added as well. Okay, so we've built these 3 email exchanges. It's a very simple set of examples. Obviously with a bigger mailbox it'll be more complicated, but really this is just for demonstration purposes, of course. So first of all, with Naive RAG, we first build the knowledge store using QDrant. One thing we just quickly do here is we build an encoder that converts these date time entries to ISO string formats. So very simple encoder just to make sure that's all string representation such that it can be embedded using the embedding models. We add the email cases to a string, and we convert these all to strings, basically in this kind of JSON format. So again, just some formatting here. We can then print these, all just printed on one line. So we now have all of the email strings represented. Again, just these three cases. So we can now convert this into array format, which makes it more ingestible by the embedding models. So we take this ISO strings, we then convert them to numeric arrays using NumPy. Again, relatively straightforward here what we do. So now we have our emails array. So we have each email is uniquely identified a entry in this list. So we have these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 emails in total in our data set of emails. Again, this is 12 emails from 3 email contexts and threads, basically. Okay, so now starting with the naive approach. So what we can first do is extract the context and metadata from the documents. So we can use QDrant collections for doing this. So the first thing we do is, we're going to use fast embed for actually getting these text embeddings. So we do from fast embed import text embedding. We also import pandas for handling kind of the data frame. So then we can have a look here just at the supported models. So these are all the different text embedding models that we can be using, and you're very welcome to play around with these and see which embedding models do and don't work in different use cases. And they all basically just take the text and embed it into a slightly different latent space using a slightly different representation. Basically, they have different speeds, different sizes, and so on. And worth looking at all of these. But for now, we're just going to use the default embedding model for the workshop, which is this BAAI BG small n, basically. But you obviously should experiment with other embedding models if you want to. So now we take this email as array string, we give the collection a name, and we just add these to the client. So we now have these 12 emails now stored, having been embedded. We now store these into the vector database like so. So very, very simple. And this is then all managed on the cloud, as I mentioned before. Okay, so now we can, well, I guess any questions so far? So we've just basically kind of embedded these 12 emails and added them to our QDrant client as the first step. And we're now going to explore how we can build simple functions to make queries and to retrieve some of these emails using simple RAG approaches. So any questions so far? Okay, no, well, I'll keep diving through them. Okay, so now we define a function which will retrieve the relevant context from the QDrant collection based on the user prompt and append this to the query. So all we do is we have the collection name, which in this case was email. We have some query, question, whatever that might be. And we can actually use the query function directly and basically get the search results directly from QDrant. And then all we do is we take the context, we basically have the system prompt that's saying you're assisting John Doe who has a query based on his emails. Your objective is to deliver a prompt response that's clear and concise, addressing his question while referencing personal information from the email threads. So we have these general instructions with all these things to keep in mind. We then have the question and then the query. So we explain the question and then the answer, and then we get the answer. And basically we give the context as well. So basically the very first thing is the context, which is retrieved from our RAG system, and then we have the question, and then we get the answer responded to by the LLM. So this is basically how we add the context before querying the final LLM, basically. And then, yeah, we have this simple query with context that also does some printing for us as well. So we then get this system prompt and this user prompt from the add context function, and then we just do some logging to kind of look at the length, look at the credits before, get the overall response, and print this in a simple way, basically. So yeah, so we can just run these two functions to get them defined. Okay, so now we can start asking some questions. So now we have a function that's able to query our email inbox with the context. So let's say, can you summarize the last few emails I received? We give the QDrant client and the name of so this is the QDrant client, the collection name, and the window size. In this case, we're going to set it to 2. So we only want to retrieve the most relevant 2 emails. So in an ideal world, we would retrieve the latest 2 emails. But obviously, you can imagine that can you summarize the last few emails I received isn't going to necessarily embed to a place that's by the 2 emails that have the most recent timestamp. That would be what would need to happen if this was going to work. And of course, that won't work. So just another indication of how, of course, naive RAG is not going to succeed here. We run this and we get, sure, I can help with that. Based on the context, it appears that you received 2 emails from Bob Smith, blah, blah, blah. Yeah, this other one is from Bob Smith, but this is not correct. That was not the latest email. The latest was actually one that came through on the 23rd of March, 2024. Oh, that's my birthday. I don't know who wrote this, but that's my 31st birthday. So that was a good day for them to email. So yeah, so from Nexus Dynamic Systems. So basically, yeah, it didn't work. Not surprisingly. Well, how about if we increase it to 5? Will that work? Well, it will load, but again, the answer is no. It's still not able to find the correct one. It thought it was, it gave some from Alex from Bob Smith, but again, not the one that we got from Nexus Dynamic. So still not able to work. What about if we increase it to 12? Well, that's the entire data set. So now the question is, can the model, given all possible data, work out which was the most recent? And this now, So this one, Actually, I'm sure I did get it right this time, but often it does. It also mentioned Alex's welcome message from DNS. Okay, so this one did at least acknowledge the email from DNS. Sorry, from NDS. So yeah, so this one did work, but again, this came at the expense of us needing to literally pass in the entire data set. So it's not surprising why this doesn't work, because if all we're doing is taking the prompt, getting some latent representation of the prompt, and finding the emails that are closest in the latent space to that, of course, what's the latest email is not going to be close in the latent space to the emails with a timestamp that's most recent or something. Like latest date and numeric dates are not going to kind of encode close together. So again, not surprising, but just a very clear indication of how naive RAG and like human-like question answering obviously often doesn't work. Oh yeah, sorry, already done this. Oh no, sorry, we're trying it now with another LLM. So now we can try it with Llama 3. Again, we get a slightly different response, and basically the output quality depends on LLM. So this actually is a much better response. Again, Llama 3 is much better than Llama 2. So again, we wrote multiple emails dated March 21st, 2024, asking about suitable time. We got the one from Jane Doe. It actually gives the dates here, which is very nice, whereas the previous one didn't give us anything like this. It was just a very long answer without any nice formatting that didn't really mention any dates. So, not great. Whereas Llama 3 has done a much better job of summarizing things for us in a very clear way. So again, just emphasis that the LLM also does matter when it comes to the quality of your RAG response. Okay, so what about some more examples? So let's now do retrieval of 2. Hello, will Jane be able to join the AI conference? Let's see if we know the answer to this. She mentioned, yeah, I think I should be able to join in response to the AI conference. Yeah, so it looks like she's planning to join the conference. Well, that's great, but actually she replied after that saying no, she can't. So again, very simple RAG where the emails are just independently stored in a vector database. Of course, you could like group the email threads together in a vector database and do all kinds of pre-processing, but the emphasis here just being that in a naive approach, it fails. We've been unable to detect that she corrected this and actually said she isn't able to join. About context length of 5, let's try and get the most relevant 5. Again, I mean, this is also the stochasticity. I think if we've run this a few times, we'll see that it does get it right eventually, but here it's actually got it wrong again. So again, just another emphasis of how brittle this agentic, so yeah, well, sometimes it gets this right, sometimes it gets it wrong. Again, another emphasis of kind of how naive RAG is not reliable here. So sometimes it gets it right because we are able to get basically all 5 emails, and one of these emails obviously articulates that she can't come. But there's really no one fits all, and even if you do get it working, you need to end up doing a lot of engineering with the retrieval window size and so on to get things working. Okay, let's try with another LLM. Just again, quickly show how easy it is to play around with these things. So we can set the endpoint to any scale. What was the name of the guy from Nexus Dynamic Solutions that sent me a couple of emails? So are we able to get it here? So like this one, haven't found any information about the guy, so can't get it there at all. What about if we increase it again? No information about the guy. Okay, so that doesn't work again. Yep, text does not identify the name of the guy again. So it seems that no matter what we do with this model, it's unable to find, the email does not contain information about the guy's name, and even with all of the emails, so it definitely has the full context. We're still, the text does not describe the person's name. Okay, so it seems as though Gemma 7b is not so smart. What about GPT-4o? So let's set it as GPT-4o. So we set the endpoint, and then let's see if this one knows the answer. Yeah, named Alex. Okay, so again, this one was able to make sense of this by actually making, by actually going through all of them and being able to reason about all of the context. So obviously, Gemma 7b got caught up because a lot of the emails were sent by the team. So Gemma 7b immediately was like, oh, it was a team. There's no individual. Therefore, we can't do it. Whereas GPT-4o can make sense of it. So again, emphasis that not only does the embedding model matter, not only does the the context window matter in simple systems, but also the summarizing model is also important, of course, as well. Okay, so some of the observed limitations of naive RAG. The most important one is just the obvious observation that the latent space of the text chunks is not likely to always be close to the latent space of the question when it's quite when it's clearly a question that requires some kind of multi-step reasoning, and it's not just about like similarity matching the semantics of the words, basically. So vulnerability to vague queries, obviously incomplete information retrieval, partly from bad LLM choice, and varied response quality as well, basically. So we've seen some of the downsides of naive RAG. Well, can we do something a bit more intelligent? So we'll now go through a smarter LLM approach. So first of all, go through some utility methods. So the first thing is we define a method that's able to get all of the email domains from the whole inbox. So this is a convenience function to get all of the different organizations we've had any interaction with, a way of kind of connecting the dots for these disconnected emails to some extent. Get all email addresses. So again, get all unique email addresses from all of the emails. There's another tool we've created. Bear in mind, neither of these use vector embeddings at all. So these are actually just kind of tools that are purely symbolically reasoned about the original text data of the emails. So these are two tools we've defined. Sorry, these are utilities. Sorry, so these are utilities that the tools will make use of. So now we define the tools. So this one does make use of the vector embedding. So this is the kind of simple search query where basically we try to find the most relevant emails to a query. So this is something that is very much in the flavor of the kind of more naive RAG approach, but we can also do so from the subject as well. So we can either look at the query, or we can find or look at for an email subject that can be used to retrieve other emails with similar subjects. So we can reason about the body of the email or the subject independently. So this is one tool we provide. So for example, here, if we look for anything that has a similar subject to AI conference, we end up getting emails that have kind of RE AI conference invite, best AI conferences to attend this year, RE conference invite. So we get all the emails that have a subject that's relevant to this. We can then look for any emails that are related to the paper reading session, and we get these ones here as well. So then we have another tool here, which is basically for fetching email addresses associated with an entity. So basically, if you can then get, if you want to find everyone that spoke to you from NDS, you can then say, I want to find everyone that's spoke to me at this organization. Again, a useful tool for our agent to make use of as it's doing its reasoning. So then we can, for example, find all the emails that are associated with Next Dynamic Solutions, and we get that we had Alex, and we also had this no reply email from the team. Find conversation. So this is interesting for finding the entire conversation between two email addresses. So if we had this back and forth between myself and Jane Doe, you can then get the entire conversation by specifying the two emails. So for example, let's try to find the conversations between John and Jane, and we get these conversations here. Accordingly, we get the entire email thread here, basically. And then this name should be a bit better, but this is actually just the latest email. So very simple, just get the latest emails. So again, this is very useful if you want to just look at some recent stuff. So being able to just like explicitly reason about the time by just getting the most recent emails. So here we get just the latest 3 emails. So that's our tools. In the interest of time, I've not gone through every line of code, but hopefully on a high level, you understand what these are for. So we can basically, yeah, we have these 4 tools we've just defined, and we add all of these into this list of tools. And what we have for each of them is a name of the tool and also tool description. So basically, this is given by the name of the function itself. Which actually could be improved, because get emails could be named better, get most recent emails or something. So there's definitely improvements we could add to our agentic system as well. So the tool has a tool name, and it has a tool description, which comes from the docs. So the name is this, and the description is this. Okay, so now we have our formatted tools. Let's actually design a system prompt for our agentic system. So this is a slightly longer prompt. We've said you're assisting John Doe with his email address. who has a query based on his emails. Your objective is to deliver a response that is clear and concise, addressing his question while referencing pertinent information from his email threads. You have access to a wide variety of tools to help you navigate this mailbox. You are responsible for using the tools in any sequence you deem appropriate to complete the task at hand. This may require breaking the task into subtasks and using different tools to complete each subtask. You have access to the following tools. So then we give these formatted tools with their names and their docs. Please answer in the same language as the question and use the following format. So you should give your thought process on how to tackle the question and which tool to use. The action, tool name, only one of the tool lists. Action inputs, the inputs to the tool in the JSON format representing the keyword arguments of the tool. And then you should always please start with a thought. So what you're kind of going to do next, basically. Please use a valid JSON format for the action input. Do not do this. So we need to double quotes, for example. If this format is used, the user will respond in the following format. So if the correct format is used, they'll respond in observation, tool response, basically. You should keep repeating the above format till you have enough information to answer the question without using any more tools. At that point, you must respond in one of the following two formats. Thought, I can answer without using any more tools. I'll use the user's language to answer and then give the answer here. Thought, I cannot answer the question with the provided tools. And then you give the final answer here as well. And then we have some important tips, just general kind of things to do. So do not rely on expanding emails to get the full conversation. Remember that the search tool will only retrieve a subset of the potentially relevant emails, and just any things that you can add to make this more clear. What ends up happening if you build out these systems is you might end up needing to add and modify this bullet point list to kind of tweak the performance. And this is where this kind of prompt engineering really starts to come in. Okay, but feel free to go through this in detail and all of these as well. But this is the system prompt we're using for the Agentic system. Oh, I didn't run this. That's why probably. Maybe that's the reason. Yeah, okay. Okay, so now we're going to use Claude Anthropic. And then we have this generate response function. On a high level, what we're doing is we first get the response, we get the observation, and then we print the thought that's come through. So again, the agent is expected to give a thought. So if there is an action that's not none, so if there is an action, we get the action and the action input. If there's an answer already, we break and we're done. Otherwise, we have an action to do. So we get the action input, we load this in this JSON format because obviously it's going to be passed to the function. And then we look at, basically we then look at what the action is, which of the tools is it. This is a little bit hard coded. Of course, we could modularize this to just use an arbitrary tool like list, but yeah, we just have these 4 tools in this case. And so if the action is search query, we look if the input arguments includes query, and if so, we do this, otherwise we do this, and so on. If it's find conversations, we use the function and get the output. So this is where we handle the tools that we've built, and we get the output of those corresponding tools. If it's decided to use a tool that doesn't exist, we get this exception that the tool doesn't exist, and then we make use of this output, and we basically append this to the messages, which then is added to the next response. Because if we've said, hey, this is the output, now I want to use a new tool, we do this again, and we just kind of do this in a cycle up to a maximum of 10 tries. And this is basically how the React agent works. It's kind of continue doing things until you're happy you're done, and then you're done, basically. So this is, in a nutshell, what this generate response function is doing. Okay, so let's put it to the test. So can you summarize the last few emails I received? So this is the prompt here. So let's see what happens. Hopefully it works. It's a bit, takes a bit of time to spin up because obviously Claude Opus is quite a big model. So I thought, summarize the latest emails, I should use the get emails tool to retrieve a reasonable number of recent emails. 5 emails should give me a good overview without being too many to summarize concisely. The latest emails cover a few different topics. There are 2 separate conversations, one with Alex from DNS about John sign up for the service, and another with Jane about an AI conference. To properly summarize, I should retrieve the full conversations for each using the Find Conversations tool. I now have the full context of the DNS conversation. It looks like John signed up for DNS, and Alex reached out to welcome him and learn more about how he found the service. John hasn't replied yet, so Alex sent a follow-up. Let me get another conversation about the AI conference for summarizing. Okay, so I can now summarize the latest emails without needing any additional information. Here's a summary of your latest email conversations. So we have the DNS welcome email summarized, the AI conference invite summarized, and in summary, the key points are as follows. Let me know if you need any of the details. So much better. This thought answer stuff is basically some internal telemetry logging. You wouldn't need this. This is part of the internal reasoning of the agent. So, if you would turn that off, you would just get this, which is a very nice, concise summary, miles apart from what was achieved with a very naive approach, of course. Okay, so what about another one? Hey, will Jen be able to attend the AI conference? So what's the reasoning here? Again, we could just go through the static ones, but I guess it's quite nice to see it unfold live and also see if it does something strange, because when it's live, it's always a bit different. To answer whether Jane will be able to attend the AI conference, I'll need to search for relevant emails first. I don't have enough context yet to determine which Jane is referring to or what AI conference is being discussed. I'll start with a broad search query to find potentially relevant emails. The search query returns some relevant emails. It looks like John Doe invited Jane Doe to an AI conference called this. However, I didn't see Jane's response. I don't know if she accepted the invite or was able to attend. To answer the question, I should follow the full email conversation between John and Jane about this conference invite, etc., etc. I can answer without using any more tools. Not be able to attend the conference. Initially, Jane said she thought she'd be able to join, but in a letter reply a few days later, she told John that something urgent came up and she won't be able to attend. So again, got the answer right. Now, I won't go through all of these. I'll leave this for you guys to go through, just so there's a bit of time for questions at the end. Well, actually, we have 10 minutes. We can go through this one, just so you have a good idea of this. So who are the researchers and their papers that accepted and declined my paper reading invitation? So let's just go through this one as well. There's only 2 more before we can talk about some of the failure points. So to find out who accepted the reading invite, I'll first glance at the emails relevant to the paper reading invitation. Once I've set up relevant emails, I'll find the full conversation threads to get more context on who accepted and declined the invitation. Search results show that Bob Smith accepted the paper reading invitation, but there is no clear indication if Alex Johnson accepted or declined. To get more context, I'll find the full conversation with Alice. Seems to be missing her reply, so it's still unclear if she accepted or declined the invitation. I'll try searching for other emails from Alice Johnson and see if there's some response. So that's quite good. It's kind of like, well, she didn't reply to email, but maybe she sent a new email. There was like a new thread, basically. Yeah, probably invitation. So yeah, so basically, it says not enough information to determine if she agreed to send or not. More emails may be needed to fully answer your question. That's not a bad response. Although even in this case, yeah, like it's a bit different every time, which is another point of the stochasticity of these LLMs. So sometimes the agent will be confident that that she's not attending because she didn't reply to the email, whereas other times it's more ambiguous. So again, like with the non-determinism LLMs, even in agentic systems, makes things more difficult. But again, a very good response here where the system is able to see she hasn't replied. So that's kind of a very good piece of information to be returned to the user, where the user can then infer that she's not able to join, basically. And again, what was the name of the guy? Going through a few more thoughts, and eventually we're able to get that the name is Alex, basically. Okay, so this is showing that agentic RAG is definitely one way of overcoming some of the shortcomings with tool use. But another downside here is that getting LLMs to adhere to the system prompts instructions is very, very challenging. It does require meticulous fine-tuning of the system prompt through testing lots of examples and continuing to tweak those examples. Furthermore, a system prompt that is effective with one model may not necessarily be effective with another one. So for example, let's try the exact same agentic system with Llama 2. So we never got any errors with Claude. It was always able to follow the instructions. But what about Llama 2? So what's the name of the guy? So again, sending the exact same one we just did at the end here. And again, it will always be a bit different. Maybe it will surprise us and get through the whole thing without making an error. But in most likelihood, it will not. Here we go. So we get this error. And why did this error happen? Well, it turns out the failure occurred because Llama 2 was not able to include the string action input, despite the system prompt's explicit instruction to always contain the function arguments accordingly. So just basically inability to strictly follow the instructions as given by the system prompt. What about mixed relay text 7b? Again, a slightly smaller model. So let's ask this: who are the researchers and their papers that accepted and declined the paper reading invitation? And again, it starts with its thought correctly, but again, we get an error. And in this case, it's because Mixed didn't generate the function arguments in the format which specified again. So just some of the concluding points here are, adhering to system prompt instructions is very, very challenging for large language models, which are obviously these text-based, non-deterministic black boxes. So getting them to be structured is hard. Of course, JSON formatting and so on can help with this. And there's increasing work to fine-tune these models to be very good at following JSON format instructions and so on. And particularly, I think GPT-4o is better at that now. But still, it still is a large language model that's a non-deterministic black box. And there's always going to be cases where it doesn't follow the instructions. And you either need to accept that the system will break sometimes, or that you have a lot of checks and balances to try to handle all of this, basically. So some of the summaries here is that adhering to system prompt instructions is challenging, very challenging, requires meticulous fine-tuning. You do need to do specific prompting for models, because the things that cause one model to fail will struggle with another one. This is why one of the reasons why we're soon adding decorators with our model router, so that you can end up kind of having model-specific logic for the routing as well. You do need to do lots of prompt refinement, and adhering to formats is very difficult, basically. So agentic systems can get you a lot further than naive RAG when you're trying to do these like quite complex talks to your data kind of applications, where naive RAG just simply isn't enough. But with any agentic system, yeah, getting non-deterministic black boxes to behave in structured ways is a constant challenge that all LLM engineers face. And this is something we've tried to just highlight here in this webinar as well, basically. That's kind of the high level. I wanted to leave a little bit of time for broad questions. Of course, the main takeaway is really agentic RAG and about RAG in general. And of course, throughout this demo, we've been using Unify to try different models, and we're using QDrant for the vector databases. But the kind of key takeaway is agentic RAG is an early field. There's a lot of work to be done. There's things you can do to improve performance, but yeah, but still, there's still wrestling with LLMs seems to be the job of lots of prompt engineers for many months and years to come, to get these things really, really working well. So I just want to say thank you very much, everyone, for joining. Obviously, we've got time for questions at the end. Hopefully that made sense and was able to kind of give you a bit of a sense of kind of the different ways of thinking about RAG, why RAG is very difficult, how you can start playing with this yourself using Unify and QDrant together. But yeah, I just want to thank everybody very much for joining and sticking with it, and I'm very, very happy to answer any questions that we might have in the next few minutes. Yeah, thank you very much. Okay, so I see.
Yeah.
I think my F. You know, it's
yeah, you're all good. I think there's a hand raise. Someone wants to ask a question.
Yes. So so Ogban, do you wanna go ahead?
Yeah, thanks. Yeah. I wanted to know, I know some not all LLMs support function calling.
Yeah.
But I wanted to know, for those that do, what sort of advantages can function calling provide for agentic RAG, at least given those models that are fine-tuned for function calling?
Yeah, well, in this case, we were just using the function calling in the kind of system prompt and the user prompt, so there was no kind of API level function calling support or anything. Basically, I think tool use in general is very important. As for so in what kind of function calling because I know OpenAI added that to the API directly.
Yeah. So I'm thinking, so there are some models that can respond with the JSON formatted. Yeah. So basically, you can pass in the tools. I think we OpenAI especially has a couple of models that do that. So you can pass in the tools, and then it responds with the JSON formatted.
So yeah, definitely massive steps towards making this more robust. But still, there are cases where it doesn't get it right. So I would say that if you're building agentic systems, generally speaking, of course, we kind of showed that, you know, Llama 2 and Mixtral, when you're just doing this at the prompt level and you're just explaining how to output the response and everything, of course, they struggle. But yeah, if you're building agentic systems like this, definitely you should start with models that support function calling in the API directly, because you're going to get much more reliability with those, basically. Yeah.
Thanks.
Sure. Yeah. Any other questions from anybody at all? I know there was quite a lot to digest, so no worries if there's not. of course, there's also lots of opportunities to ask questions on Discord and everything as well. Any thoughts? I mean, any kind of additional comments and things related to the quadrant side of things, or RAG more broadly, you want to add at all, Atita? I'm putting you on the spot a bit.
Yeah, no, I think it's all good. I think there's a very decent question from Bharat, who is asking that. Oh, I think he wants to probably come online.
Yeah, do you want to ask it? Yeah. Hey, bro, how's it going?
Hey, hi, Daniel. How are you?
Yeah, not too bad. We're catching up soon, actually, as well, aren't we?
Yes, yes, we are.
Okay. Good to see you.
Yeah, so I had a quick question about agentic RAG. So does it scale with the data? Does it affect the latency of the agent's response?
Yeah, so the latency is definitely increased. So as you can see, well, actually I don't have it up now, but I mean, I can quickly share my screen again. As you can kind of see from some of these responses, right? Like you have this kind of several steps of thought. So you get the thought, you get the thought, you get the thought, you get the thought, then you get the answer. And all of this at the moment was using Claude Opus. So you might be waiting 3, 4, 5 seconds to get a response. Of course, in general, the cost and speed of these will go down. This is also obviously a case where, which is what we'll be demonstrating. We were going to try and get it into this webinar as well, but we thought there was just a lot to share in terms of the interesting side of agentic RAG in general. But this is where the router can come in. Obviously, if some of these questions can be handled with a smaller model, some of them need the big models, but some of them can be handled with a smaller model, then you can improve the cost and the latency of these systems. But yeah, you're absolutely right. Generally speaking, people are trying to get things working first, and that involves using expensive, high-quality models in this complex multi-step approach. And then once they get it working, you're left with a very expensive, very slow system that then you want to optimize. And that's where things like routing and prompt optimization and stuff come into play as well. But yeah, you can get quite a big delay for sure.
Yeah, makes total sense. But thanks for answering this. And
of course,
I'll catch up with you in the weekend. Yep.
Yeah, looking forward to catching up soon.
Yeah.
Well, yeah, good to hear. John Fly says, obviously working very closely with you as well, John. But yeah, good info and good demo. We're working through similar maturation in the process. Yeah, it's definitely, I think everybody that's dealing with LLMs is finding similar pains. Yeah, I don't know. How does this resonate? I mean, not to put you on the spot too much, John, but like, how does this relate to some of the stuff you're doing at the moment?
So very close. I mean, so Firm Pilot, we do, law content for lawyers. And so our content has to be entertaining, but highly accurate.
Yeah.
And so having, throwing our data in a big heap and just using like semantic and similarity searches through vector databases as the only solution, like that doesn't cut it. So we're in the process of adding, like enriching our ecosystem like this.
Yeah. No, makes sense. Well, definitely, kind of happy to share our thoughts as you go through that process, because we're kind of, I don't know, getting better over time at building these applications. But certainly, I think everybody, even the kind of most sophisticated agentic software companies, everyone just has the same issue of constantly wrestling with the prompts to try to get it working and fine tuning things, and it's just part of the game, I guess.
I think.
Cool. Okay.
I think one thing that I would like to add is that the repo where this notebook is present, I mean, I already shared that in the link as well. So you will find different ways in which you could implement RAG using QDrant and other tools. And also the repo is also useful in case you want to use any evaluation tool. So that is also something that you can explore. So you would find different variants of building naive RAG and hybrid RAG and RAG with re-rankers. So you would find a lot of information here. Hope this is also useful.
Yeah, definitely. So definitely obviously QDrant and then QDrant RAG eval is a great repo to go to. And again, for this particular notebook, we have it all here basically. Amazing. Also, what is the thought in the system prompt and the response? Is it decoding the emails for a number of iterations and finally providing the direct summary? So what I would say on this, if you've not read the paper React, Pragadish, then I would suggest reading the paper React. I mean, if you type like LLM React, I guess, React prompting, React. So give this a read. It's obviously this very popular paper, 1,000 citations. Give that a read. Obviously, if you then go through the code you should, this generate response code, you should start to get it. And you can step through this. If you want to just run the notebook and put some breakpoints in and just see what's going on, you can get an idea. But basically, we're asking the agent, the LLM, to basically give a thought about what it should do next, deciding what tool to use, and then it uses that tool by giving the name and the arguments, and then we get the output, and then it has another thought. So it's basically just the planning. It's kind of this incremental step-by-step planning that the LLM does as it's getting the response, basically. But if you read the paper React, it's the same approach, basically. Yeah. Cool. Any final questions from anybody at all before we wrap up? Okay, well, we're at time, so I guess we can wrap up there. But again, thank you so much for joining, everybody. This was really, really a lot of fun. Really happy to see so many people in the audience. And thanks to Atita for putting this together as well, and putting the slide together and doing this, collaborating on this. It was really, really great to work with you on this. And as for our side, we'll be having more webinars. We have another webinar next week. I believe we're doing, we're trying to do one every week. We think these are really great opportunities to work with lots of awesome technology and everything. So I've forgotten what we're doing next week, but we have one with Copilot Kit lined up quite soon. We have a few more, so stay tuned for more updates. Maybe when we have some more cool stuff, we can do another one with QDrant at some point again in the coming months, later in the year or something. But yeah, thank you very much, everyone, for joining, and have a great day, everyone, and see you guys all again soon.
Thank
Thanks a lot, guys.
Bye.
Bye.